Okay, so in this example, what I have here is that if we have sine theta, let's say theta is an angle, so if we have sine theta equals 3 over 8 and theta is in quadrant 2, find cosine theta. So what needs to be highlighted in this problem is that the sine theta, or more generally, we have one of the two trig functions we have learned previously given. So the two trigonometric functions we have learned previously here is either the sine function or the cosine function. So here we're starting out with having one of the trig functions given. And then the next important piece of information is that theta is known to be in quadrant 2. And then our work here is to find the other trig function. And in what we have learned so far, the other trig function is going to be the cosine of theta. So now looking over into my working board here, then we have learned in the lecture that, and the important property now is that sine square of theta plus cosine square of theta equals 1. And throughout the lecture I was saying that this identity right here, this trig identity, is a fundamental trig identity because we're going to be using that a lot, and it's anywhere we're working with trigonometry. Be aware that this identity will be useful, and it's always true. And so sine square of theta plus cosine square of theta equals 1. And so in our example here, in our problem here, currently we're given that sine of theta is known to be 3/8. And so I can now go ahead and substitute that value into my current identity right here, and here's what it becomes. So sine square theta plus cosine square theta equals 1 will become, after substituting the value of sine theta into the identity, I'm going to have 3/8 square plus cosine square of theta equals 1. And so at this moment, then how I see that now is that I'm looking at and by the way, 3/8 square is going to give me a 9/64 as a fraction, and plus cosine square theta to equal 1. And so continue further down, I can just at this point entirely see cosine theta as an expression, and what we have here is a cosine square of theta equals 1. And remember how we talked throughout the lecture we discussed throughout the lecture that this cosine square theta means it's a cosine of theta expression but being squared. And so I can go ahead and subtract 9/64 from both sides of the equation, and that leads me into having my next equation here is cosine square of theta equals 1 minus 9/64. And so doing a little quick math here, it gives me cosine square theta is to equal 55/64. And so now, keep in mind that in the entire problem here, we actually do not need to find out what theta is. So finding the value of theta is not really our main goal of the problem. All we need is to find but we do need to find the cosine theta, the value of cosine theta. And here we actually close. So now to find cosine theta, the value of cosine theta, all you need to do now is to do the usual operation, taking square root on both sides. So consequently, cosine theta will come out being, but now everybody in this class have learned enough pre-calculus, understanding that anytime you're taking a square root on both sides of an equation, then you have to take a plus and minus square root. And this practice will happen a lot throughout our course in trigonometry. But so here, coming right out from that equation there, then cosine theta turns out to be plus and minus square root of 55 over 64. If we're looking a little more closely into our current step of the equation, saying cosine theta can actually be either plus or minus square root of 55.64. We are at this step where we need to make a choice right here. The idea now is that which one of the sign would be our sign of the correct answer. Now, so it's time to use that other piece of information here. The problem set angle theta is in, and I'm using this symbol here. Once again, this symbol of mine means is in or is an element. So angle theta is in quadrant 2. So allow me to quickly explain, but we've seen through the video lectures that the entire unit circle is broken down into 4 separate quadrants. Here's quadrant 1, quadrant 2 is here, there's quadrant 3, then here finally quadrant 4. So this statement is indicating that your angle must be located somewhere in here. And so now for that angle itself right here, being inside of quadrant 2, then strictly the x coordinates of any terminal point in quadrant 2 must be a negative x coordinate. And then likewise, but in similar argument, y coordinate in the quadrant 2 has to be a positive. And so I hope you understand my minus comma plus right there. It's indicating the x coordinate for any terminal point in quadrant 2 has to be a negative sign, and any y value in quadrant 2 has to be a positive sign. And so that leads to our conclusion that since theta is in Q2 right there, and we're looking for cosine value, and remind yourself from our first understanding that cosine is equivalent to the x coordinate. And so now the two answer choices here, we must, so therefore, we're now making our conclusion that cosine of theta has to equals negative square root of 55 over 64. All of that there being inside of square root. And so now the last thing here is just to simplify down that square root expression. But as far as the final answer, this is our final answer. We solved that by taking the square root on both sides, and then so we made our choice by relying on the quadrant understanding, and then we made our choice to go with the negative answer. And so square root of 55 over 64 can be reduced down to, so cosine of theta is indeed negative square root of 55 over 8. For square root can be distributed into two separate parts of the fraction, and the negative sign is here, and that's how it leads to that. And so before I'm closing down the example, the whole point of this type of problem is that we can, once you are given one of the trig function value and is asked to find the other value, and knowing that your angle theta is currently being in some of the 4 quadrants, you don't need to find the actual value of theta. So no need to find the actual value of the angle in this problem. All right. So now after having some good experience throughout the earlier example, let's repeat. Let's do a different example where it's almost identical. So here what we have here is an example where we have if cosine theta equals 1/7. So that is one valuable piece of information. And theta is known to be in quadrant 4. Let's find sine theta. And so here, once again, back into my working board here. Then start out with sine square of theta. And this time, since we've had some experience through the earlier example, allowed me to start picking up the pace here. But sine square of theta plus cosine square of theta, famously known to be equals 1. And so in this case, in our case here, we have cosine theta given to be the ratio 1/7. Then now what I can do now, I'm going to take that value and substitute that into my cosine square expression here. And consequently, that gives me, so in my next step, it gives me sine square of theta plus, but instead of saying cosine square theta, I'm now going to say, since cosine theta equals 1/7, so now I'm looking at plus 1/7 square, in parentheses square, equals 1. And 1/7 square is the same as, in another step, writing it down, sine square theta plus 1/49 equals 1. And so now we keep getting closer and closer to being able to find the final correct answer. So the next step I'm doing now is to subtract 1/49 from both sides, leaving me on the right hand side 1 minus 1/49. And calculation shows that sine square theta is equals to 48/49. And so now, finding sine theta, I am going to, and since being a perfect square expression here, then I'm going to find sine theta specifically by taking the positive and negative. So any time that we're taking the square root or about to take the square root of both sides, please think of doing the plus and minus here. So sine theta can equals plus or minus square root of 48/49. And now we're about to make our choice to find out which one must be the correct answers, the correct signs of your answer here. And so let's utilize the information regarding your angle. So we actually going to choose sine theta to equals the negative square root of 48/49. For the reason being because our angle theta is in Q4. And so quickly why that is again, we can think of the unit circle. Quadrant 4 is here. And so any angle theta being this, that has a terminal side lands into quadrant 4 is expected to have a negative positive x value but negative y coordinates. And that is my reason why I choose my sine value to be a negative sign. And the calculation here is simply coming out from doing the math work. And so now our last step here is to finalize the answer by reducing that square root expression. And so my final answer is going to be sine of theta equals negative square root of 48 over 7. And in case you remember, but square root of 48 can also be reduced further to be negative, no, 4 outside of square root multiplied with square root 3 over 7. Many of the problem, throughout many of the homework problem and many of the example problems will require you to reduce your square root expression all the way to the end like this. Even though I put a box inside your answer here indicating when you get to that point, we're actually done with the answer. But a lot of time, even I and many other instructors are requiring you to be able to put your final answer in a most reduced form like this.